there's a reason that x squared plus that x is greater than or equal to 0 is there. It's not anything to bother you. Just kind of ignore it. We'll kind of talk today about why that's there. But this f of x is really a y. When you write an inverse, what does y become? X. And what does x become? So x is y to the fourth minus 9. Now what are you going to do next? You're going to add 9. Do not worry. Do not be the kid who tries to attack this fourth power. You know, you can't change your brake pads without taking the wheel off first, so worry about it later. X plus 9 is y to the fourth. Austin, what's the opposite of the fourth power? The 1/4 power, the reciprocal of 4. So you raise both sides to the quarter power. And 4 times a quarter is what, kids? 1. So that frees up y. Now what are you supposed to replace y with? Yeah. I don't know if I answered this one on the answer document, but it's very possible that I wrote this out as a radical. It wouldn't surprise me if I did. I didn't. I could have, though. What root are you taking? Fourth root. Now, you take a multiple choice test. Don't be surprised if the author of that test decides to write the answer as a radical, because they're assessing you for what you know. How much do you really know? You're not trying to be confusing. You're trying to see how much you really know. What you got, Trey?
Can you slide over?
Sorry. What number? 2. Is it the fractions?
Not really. I just got into a place where I could go any farther, so I won't.
What's your first line say, Grant?
Subtracted the 7/5. Or will it be x?
So you have x minus 7/5 equals negative 3/5 y. Hey, there's a step that, you know, first off, this f of x becomes x, that x becomes y. That's actually what his first line is supposed to say. Right? So I agree with that. You subtract 7/5. What's the problem?
Well, the 5/3.
Oh, you got scared of the fractions. Why don't you tackle it in 2 steps? You know, you don't necessarily have to do everything all at once. Why don't you try to tackle things in 2 different steps? That negative 3/5 of y is a negative 3 times a y, and it's also a y divided by what? 5. You know, maybe you should approach it from 2 steps instead of 1 big step. A lot of kids need to approach things in 2 steps. And it makes sense to do that with a fraction too. If you multiply the right-hand side by a 5, what happens to 5 up high and down low? They cancel. Why are you late today, Casoda? Why are you late today? Now what do you need to do with that 5 on the left? Distribute. 5 times x is 5x. When you distribute to this negative 7/5, you have a 5 up high, 5 down low. What do? They cancel out, so minus 7. And that's equal to a negative 3y. Divide by the negative 3. So you'd have a negative 5/3 x.
Negative 3y is 3.
It's just y.
Yeah.
Yeah.
Let's say we just look at y.
That's the goal, isn't it? Goal is to solve for y. Of course, you weren't here. What do you replace that y with? All right, so the inverse of f of x is a negative 5/3 x plus 7/3. Which is what the answer document hopefully says. What else you want to see? What you got, Austin?
7. I was confused with that.
All right, so first step is that guy's a y. Sorry, that guy's an x. That guy's a y.
What's the key there?
What's the y that's cubed?
The y.
The first step in writing an inverse is to swap x and y. That's literally what you do. Y becomes x, x becomes y. So Austin, what threw you off about this? All right. Well, you can't do anything with y cubed until you remove the negative 1 over 64th. Multiply by negative 64, which some kids get and some don't. I'll talk about it in a second, but negative 64x equals y cubed. Some kids will say, well, I'll divide by a negative 1/64th, but they can't do it when there's an x. Well, what number is in front of that x? So you do 1 divided by a negative 1 over 64. Now, they're smart enough to know they need to do division. They just struggle. Either way, you get negative 64. Now, what's the opposite of cubing? Cube rooting. Remember, you got to isolate the power before you fix the power. You can take the cubed root. You can raise to the 1/3. Doesn't anybody care? I probably on your key actually did the cubic root. Did not? Did? Okay. Do I have a negative 4x to the 1/3 though as the answer? Because what's the cubic root of negative 64? Negative 4. So this is negative 4 cubic roots of x, which I have written as negative 4x to the 1/3 power. I'm not going to worry about replacing f of x right now. That's where the answer came from. What else you need to see? 22. Yeah. To do 22, what I did is I converted both of them into powers. I converted them into exponential form. We have an exponent. X to the 6/4 sitting over x to the 5/7. All right, what's the deal on division and exponents? Subtract. 6/4 is greater than 5/7, by the way. It's 3/2. That's 21. It's 11/14. I think the key might be wrong on this one.
21st root of x to the 20th.
Yeah, that's probably wrong. 7 times 3 is 21. 2 times 5 is 10. So this should be over 11/14, which is not what the key is going to say. I bet I have a problem with these. A lot of times I'll write 4/6. And I know I did that one in my head because I remember doing it. Yeah, it's that number right there. That actually should be the answer to this thing. But it's written as a radical. It's the 14th root of x to the 11th. But I put money on it. What I did is I did x to the 4/6 and x to the 7/5 in my head. Because I do have an issue doing that from time to time. What number? 20. What I would do on 20 is, since the top is a cubed root and the bottom is a cubed root, I'd view it as one big cubed root. Because then you'll see what you can do. You may not realize it when you first look at it, but can't you throw away the x's? Once you rewrite it as a big root, you can start seeing that there's stuff you can do. You have a y to the 7th over a y, which is y to the 6th. You throw that one away, and you decrease the exponent. So we're actually looking at the cubic root of y to the 6th z squared. It's not hard to take a cubic root of a number. How many times 3 under 6? Twice. So sitting out front is a y to what power? Squared. Can you take the cubic root of z squared? Nope. Stuck inside. Y squared, cubic root z squared. Anything else? 8 to be where I stop. All right, so f of x becomes, f of x is y. It becomes x. The 3x becomes 3y. 6x becomes 6y. Now, I was telling you all to cross multiply on these. That means you link these together. What is x times 6y? 6xy. What is x times a negative 5? 5x equal to, there's an equal sign. A lot of kids throw in a divisor. Equal to the product of 1 and 3y plus 4. Now remember, when you first started solving for x, you put everything with an x on one side and everything with a number on the other. Here you're solving for y, so everything with a y on one side and everything else on the other. 6xy has a y. What else has a y? So jump it over. Everything else, other side of the equation. 5x has no y. Move it over. It belongs before the 4. And you follow commandment number 1. Pull the y. Pull the what? Okay. I thought you said pull something else. Pull the y. You can actually pull a little more than that, but it doesn't make sense on these to do it. You could pull a 3y if you wanted to. But then you have to turn around and divide it out. So you have y times 6x minus 3 equals 5x plus 4. What do you divide by? And that is it. So I did 1, 2, 3, 4, 6 of your homework problems. That's not due today. Did we finish the lesson? No, we did not. Again, I can't print off copies of notes right now. I gotta save what toner I got for when I make master copies. Anybody need a blank copy? I still got some of those left. Anybody need a blank copy? I still got blanks. I just don't have, I can't print you all done. I give you blank copies, just can't print off what we've done. Not till toner comes in. So that's where we left off yesterday. We verified the easy way with symmetry in a calculator. Well, now we're going to verify using what it says up here. Two functions are inverses if f of the inverse is x and the inverse of f of x is x. I know the notation's kind of funky. Don't let it be funky. The first thing we're going to find is f of its inverse of x. Well, that means you're going to take this piece right here and put it where? Right there. That's all it means. Plug the inverse back in the original equation. So 3, the x is encountered. 1/3 x plus 5/3 minus 5. That's just a plug-in set. And then kind of go with your gut. What do you think you should do? Distribute 3. What's 3 times a third? 1x. You distribute to the 5/3. What do 3s do? They cancel. 3 up high, 3 down low. They're gone, kids. That's how it works, isn't it? Right, Trey? You got 3 up high and 3 down low? Gone. What's left? 5. You got plus 5, then you have that minus 5. Right there. Cancel. Get your x. Now, I have seen a rare occasion where one of them works and one of them doesn't. So you got to test the other one too, just to make sure. Of course, we already know it's an equal. Don't we already know the inverses? Yeah, we looked at the graph. Now you're going to find the inverse of x, of f of x, composed with f of x. So it's kind of backwards. But you take this guy and you put him there. It's just function codes. So I see the third, and what then I see the x, and x gets replaced with 3x minus 5 plus 5/3. Done. Get x. I know some of you guys are better at math than others, but if you take a third and you multiply it by -5, where does the multiplication happen? Up high or down low? Up high. Division's down low. You get a -5/3. That's one of the things that's killing a lot of y'all. Every little thing you have to go to a calculator to do. Every little thing you got to go to that calculator to do. But anyways, you got a positive 5/3 and a negative 5/3. They're gone. They left it. That follows the theorem. The theorem says if you compose a function and its inverse, and the inverse and the function, you get x in both situations. They are inverses. So that's an easy skill. If you ever have to know that, I'll tell you what to do, because you probably won't ever remember it. Let's see, we did that, we did that. So here we are. Concept, a one-to-one function. Function is a relationship where every x has one y. A one-to-one function is where every x has exactly one y. You remember talking about functions with either your algebra 1 teacher or me, or algebra 2 teacher, they told you functions x is cheap, right? They can like more than one y. One-to-one is legit. It's, dating somebody and being loyal to them. These are mutually exclusive relationships, which basically means no one cheats. You ever heard the term mutually exclusive? You got a girlfriend? Just the one? That means you're mutually exclusive. As long as she's not seeing anybody else. Mutually exclusive means that you are exclusive to each other. And then we also have something else we've talked about in Algebra 1. It's called the horizontal line test. I think, Sam, you mentioned the vertical line test yesterday.
Pardon this interruption. Teachers, I need you to check your email at this time or in the next 5 minutes or so. Thank you.
I bet the fire marshal is here. They make a big deal out of that because they don't want to get written up. Yeah, no, I did. Oh no, it's about the COVID vaccine.
It's not open yet.
No, it's open to me.
Yeah, it's not open.
No. That's just me, though. I'm sorry. I shouldn't say things like that. You want to take it? Take it. You don't? Don't.
Well, if you're healthy enough, you don't really need it.
But that's not entirely true. It's just kind of luck of the draw. People die of the cold, the flu. They die of the complications of them. I've eaten too much candy. It's called diabetes. Me personally, no, I don't take it. So yes, I did spell function wrong, but it is 1-to-1 if and only if its graph is intersected by a horizontal line exactly one time. Only 1-to-1. So up next, should be a situation we talk about. Hopefully I can explain why that makes it 1-to-1. So let's jump ahead to where that does happen. No. Okay, let's insert a page.
Insert.
You guys can't do that. Let's see. Are the functions shown 1, 2, 1? Yes. Because horizontal lines only touch how many times? Once, right? Now, the fact that a horizontal line only crosses it once means that the x only has one y, or vice versa. That's what it means. Do something simple. It's like y equals x squared, which is a function by definition. But is it 1-to-1?
No, because punches
It doesn't.
Fails a horizontal line test. What's happening here is that y values are not mutually exclusive to an x. This is not 1-to-1. Y cheats. So x might be faithful, x might be in love, x might have a ring in its pocket. Y likes somebody else. By the way, would that be the male or the female chromosome? Which one of y'all is the Y? The Y is the male. That's how it works. Male chromosome, XY. Although 2021, that's not true anymore. I bet they put me through like sensitivity training sometime soon. They're gonna have to. All right, so here we get to drawing the inverse of a function. There's a couple of questions here before we actually draw its inverse. Does anybody know what this is the graph of? That is x squared. That is y equals x squared. It is, all day long. That is y equals x squared. You take a 1 and you square it. What do you get back? 1. You take a -1 and you square it. What do you get back? You get positive. This is y equals x squared. Now, graphing the inverse is actually pretty simple. You don't actually have to write the equation out. What's the first step in actually writing inverse equations?
turn away some
X and Y swap. Same thing with graphing. swap the x and y values. Now, before I actually do anything, well, let's go ahead and do this, because it's kind of a learning thing. We're going to swap the x and y values. This point, -1, 1, becomes what? 1 negative 1. The point 0, 0, what's it say? It becomes 0, 0. And your point 1, 1, no, it becomes 1, 1. So the only thing that actually changed, looks funny, is 1 negative. The inverse is still at 0, 0. It's still at 1, 1. But this guy has become 1 negative. That's the inverse. Is the inverse a function? Oh, you remembered something. Good for you. Take that grid off. I'm going to take that grid off before I gave you notes. The inverse is not a function because fails. Sean said the vertical line test. Which it does. Vertical line hits it twice. Because the x's have 2 y's. That's not allowed to happen and be a function. There's more to this. The original function was not 1-to-1. Only 1-to-1 functions have inverses. They're the only ones that do. Now, there was a problem I mentioned on your homework. Christina asked it. I think Christina was afraid of the x greater than or equal to 0. Is that what bothered you? Okay. So I'll give you all a minute or two to copy this down. Then I'm actually going to go back and talk about number 4 on your homework in greater detail. You don't have to have your homework out. I'll put it up here. It doesn't change our answer, kids. What we wrote is right. What we wrote is right. That was number 4 on your homework. It had the provided x greater than or equal to 0. The reason that was there is because it forced graph only to draw half of it to be drawn. You put a restriction like that x is greater than or equal to 0, it only forces half the graph to be drawn, which makes the graph 1-to-1, which means you can find the inverse. That was the whole point of this. That makes the graph 1-to-1. it has an inverse. That was the whole point of that being there. It didn't mean anything to you though. You were fine.
So anytime you see X's,
Anytime you see a restriction like that, they're just telling you this enables you to actually find an inverse. That's all it does. The fact that that's there means that you can write an inverse.
could be less than 0.
Could be anything. Could be greater than 4. But that is a restriction letting you know that they have decided to make this thing 1-to-1. And there's some more stuff in your notes about this, but I want to talk about that problem specifically because it was asked about, and I knew that's why she was concerned about it. All right. Another one of these, graphing an inverse continued. Anybody know what function this is? That is x to what? No. You graphed it in here. Starts low, ends high. The third, according to Sean, and Sean is right.
Yes.
Y equals x cubed. You take a 2 and you most say 2 times 2 times 2, what do you get? 8. You take a negative 2 and you say negative 2 times negative 2 times negative 2, what do you get? That's y equals x cubed. By the way, is this thing 1-to-1?
Yes.
Yes, it will pass the horizontal line test, which means that it has an inverse. Now to graph its inverse, what do we do with x and y? Swap them. The only points that I'm really concerned about here are actually the 2, 8 and the negative 2, 8. Because if you swap 1, 1, what's it become? If you swap negative 1, negative 1, what's it become? Yeah. So we're just going to swap these points 2 and 8. We're going to swap x and y. And this point 2, 8 is transformed to become 8, 2. And this point negative 2, negative 8 becomes what? Negative 8, negative 2. Your grid only goes back to 7, so you could extend it just a little bit. Does it go to 8? Oh, I can't count. Sorry, it's right there. Then you've got that point 8, 2. It's actually right there.
This one is a function.
Yeah, this one is a function because I can draw this one.
That is 1-1.
The original function was 1-to-1. I missed the origin a little bit there. When you miss the origin, you just make the origin bigger. That's what I want to do. The inverse is a function because it passes what test? Vertical. And of course it is. The original function was 1-to-1. If the original function is 1-to-1, the inverse is still going to be a function. Do you know what the inverse of x cubed is? Nope, that's literally opposite. What is the opposite of cubing?
1/3.
1/3.
I just graphed it here.
I was hoping to do without technology, but
Well, I thought it was.
this is a cubic root of x. Where Sean says 1/3 power. The opposite power of the third power is not -3. That's a sign deal. The opposite reaction is take cube root. An inverse more or less means opposite action. That's what it means. It does the exact opposite thing. Do you see a line of reflection up there? Y equals x. You think you got that from the notes. But the line of reflection for all of these, line of symmetry, is y equals x. My grid's a little bit off, but it's there. That's what you flip on. That's what you hot dog over. All right, anybody got any questions? Probably not. Determine if the graphs of the following functions have inverses. How about the first one? No. It's not 1-to-1. do you know it's not 1 to 1?
Because it doesn't pass the horizontal test.
Failed. I'm gonna say HT. I'm getting tired of writing horizontal in tests. No, it doesn't either.
That's not even a function.
It's not a function. Sean knew it wasn't a function. John remembered those quick 5-minute lessons in Algebra 1. How do you know it's not a function? Spelled vertical. Not a function automatically. Circles are not functions.
The next one, red.
Yes.
So then what would you say?
It is a function.
That's a function.
It passes the HT.
Passes HT.
X,
Now, by the way, what is the inverse?
X to the third.
Sean says y equals x cubed, because the opposite of cube rooting is cubing. Does anybody know how to make maybe the first or second one doable? Make a restriction? What if we put a restriction? What if we said x is greater than or equal to 0? I would have put a restriction like that.
You're going to cut off the negative half.
That little block over it. That's all I would have seen. Would I have been able to invert that? No. Circle. I mean, you could have done this block on either side. You could have also done less than equal to 0. Either one of those would have made that thing inverted. The circle. It's not quite centered.
Greater than or equal to 0.
Whatever that means.
X is greater than or equal to 0.
Actually, you still couldn't do it. It's still not a function.
Then y is greater than or equal to 0.
Circles are not inverted. That's what I'm trying to get to. Even if I cover up half the graph on the circle, do I have a function? No. Circles are not inverted. Doesn't even make sense to invert a circle.
And cut off the bottom part.
What's the opposite of circle?
Square.
No.
Circle.
Circles are not inverted. All right, so determine if the following ones have graphs, or have inverses. Negative x cubed plus 5 divided x is greater than or equal to 0. Heck, we just did that. Does that have an inverse? Yes, it does. The other one, I left the graph blank. Now, why would I do such a thing?
So we can do it ourselves.
So I can talk about it for tomorrow. Because tomorrow we learn how to graph the square root function. So it's called pre-teaching. What's the smallest number you can take the square root of? You type root 2 in your calculator.
4, my bad.
4.
It's not 4. What is it, Christina? 0.
She said 0, so I'm going to see that.
X root x. The smallest number you can take the square root of is 0, and the square root of 0 is what?
0.
What's the second smallest thing you can take the square root of? No! 1. It's 1. The square root of 1 is? This explains so much. What's the third smallest thing you can take the square root of? No! I've been over this. What's the root of 4? God, I'm not a spitter. Keep me covered going wrong. Come on, kids. You're better off hitting yourself in the head with this thing than using it.
So 6.
Probably lives up there. Why'd I do that?
You get the inverse, so you can graph it.
I have 3 points. All you 3 points. Almost everything we do in here, how many points do I plot? 3. 0, 0, 1, 1, 4, 2. We call the square root of x arm. Because that's kind of what it looks like. That's kind of how you remember it. Square root of x looks like an arm. Does it have an inverse?
Yes.
Yes, because it's going to pass the horizontal test. What is its inverse? X squared. the opposite action. Hey, look at that, we're almost done. We did that one,
We
we did that one. Only thing we didn't do is the word problem. It's about NFL. Average price for a National Football League ticket can be modeled by P, which P stands for what? Price. 35T to the 192nd thousandths, where T is the number of years since 95. Find the inverse. No, that's not too hard. The inverse here, we're not using X and Y's, we're using P's and T's.
So just swap to T.
So P becomes
T.
T. And T becomes P. Now, isolate the P, because the goal is to resolve the price, right? So what are you going to divide out? 35 equals, sorry, 35. I wrote that completely wrong. 35 is, T is sitting over 35, and that equals P to the 0.192. What is the opposite action of a 192 thousandths? Rewrite the decimal direction. I'm saying 192 thousandths. The reason I'm saying that, 0.192 is 192 over 1,000. That's why knowing how to pronounce things actually helps. You can pronounce it as 192,000 when you look at it in a fraction. What's the opposite power of 192 over 1,000?
1,000 over.
1,000 over 192. You raise both sides to that power.
Are you able to simplify this that fraction?
Of course you could. I'm not going to. Here's your price. And we're actually going to say that like that. Just go ahead and call it the inverse because that's what it is. And it wouldn't be of X anymore, it'd be of T. So this is a function that you give it the number of tickets that you sell and it gives you the price, as opposed to having the price and knowing how many tickets you sell. And you're a fool if you don't think Big Business does that. Because they do. Supply and demand. I guess we won't be able to see, but, you know, we just want to. Y'all enjoy the remainder of your day. Hopefully you get sent home to lunch. Hopefully it starts snowing.
But it's Tennessee. I mean.
Now, I guess if you're at home, hopefully it snows enough for you to make a snowman or something.